I'm hoping everyone can hear me clearly. So I'm here today to present on the 100 largest losses in the hydrocarbon industry, which is a Marsh JLT Specialty publication. And then, as Lee mentioned, he'll do a few slides at the end on the Energy Institute's process safety management framework that should hopefully dovetail nicely with what I will be talking about today. So just as to go over the agenda, so I'll give a bit of an introduction into myself and who Marsh JLT Specialty are, and then I'll talk on sort of three main topics relating to the 100 largest losses publication. So what can we learn from the last 2 years of loss events? So 30 years on, is history repeating itself? What's the significance of age with assets and losses? I will then go on to a small segment on ammonium nitrate explosions insight, following on from the Beirut incident back in August 2020. And then Lee will do his segment on the process safety management framework. So as a way of introduction, as I mentioned, my name's Alex Watney. I'm a risk engineer with Marsh JLT Specialty based in Dubai. And I'm also a committee member of the Energy Institute Middle East branch as well. So my background, I'm a chartered chemical engineer, and before I joined Marsh, I spent almost 10 years in industry in various sort of production technical roles for companies such as Total, BG Group, and then latterly Shell, primarily in the upstream industry, working into the UK North Sea, but I also spent a bit of time as a process engineer in the refinery industry as well. I now work as a risk engineer for Marsh, helping to advise energy clients on risk management and process safety for the purposes of energy insurance. I'll just give a little bit of background on Marsh to sort of set the scene, and then we'll go into the main body of the slide. So Marsh is one of the largest global insurance brokers, has approximately 35,000 employees globally, and serves clients all over the world in 130 different countries. I specifically work within the Energy and Power Specialty division, and then specifically within the Global Energy Risk Engineering team. And we help to provide advice and expertise to energy companies on risk management and process safety relating to their insurance and insurance issues. And we have a large team of over 40 engineers from industry backgrounds that conduct over 400 risk engineering surveys with energy clients each year. And we have expertise in all different areas, upstream, refining, petrochemicals, terminals, and power, and also moving into renewables. And what we try and assist clients with is, providing, noticing where there's any maybe gaps in their risk management and process safety versus industry good practice. So today I'm here to talk about the 100 largest losses in the hydrocarbon industry. And this is a publication that Marsh produces reissues every 2 to 3 years, with the most recent publication coming in March 2020. And it provides details on the largest 100 losses in the energy and hydrocarbon industry based on insurance loss data. So this is primarily looking at property damage values. So that's, damage to equipment, machinery, vessels, sites, etc. That's just property based, that could have occurred from fires or explosions or collisions, etc. This data doesn't include business interruption, so loss of earnings or any sort of third-party liability values. So hence, while like an event such as Deepwater Horizon features in the top 100 list, it's not number one, because most of the value that gets quoted around Deepwater Horizon is third-party liability. And also this publication provides insight into loss trend. So what can we learn over the last 2 years of losses? Is history repeating itself, and how much of a factor is asset age? So just some of the key points to note. So in the 100 largest property damage losses, it totals around $43 billion US. And the 100th largest loss, so the smallest one in the list, is around $175 million. And you can see here the property damage loss by year, and you can definitely see there's certain spikes in history. So around 1988-89 was a particular period of large number of losses, and there's also been a few as well in the last 2 years, so 2018 and 19 as well. So if we look at the spread of the losses over the globe and over the last sort of 30 years or so, sort of longer than that, since 1974. So you can see there is a big spread all over the world. There's a bit of concentrations around North America and Europe because of the pure number of facilities located in these areas, and somewhat to do with the age of the assets as well. So I'm sure many people will be familiar with some of the top 10 loss events. So Piper Alpha is the largest in our list, at just over $2 billion US. So this is a adjusted property damage loss for December 2019. So effectively a inflated cost. So that was, as most people probably know, Piper Alpha was a fire and explosion event in the UK North Sea. You've got Phillips Pasadena in Texas in 1989. That's around $1.6 billion. There's Ekofisk in the North Sea. That was 2009. That was a vessel collision with an offshore platform that caused almost $1 billion of damage. There's Baker, Gulf of Mexico, 1989, fire and explosion event. Campos Basin in Brazil, 905 million, again, explosion and fire and explosion. Esso Longford in Australia, another sort of famous process safety case, 1998. So that's just a few of the high-level ones that people might be aware of. And then we've also shown there the split between the different industry sectors. So refining is the largest, about almost $15 billion, and then closely followed by upstream as well at $13 billion. And then you've got petrochemicals, which is slightly lower, and gas processing and terminals, which are sort of relatively small percentages, largely because they tend to have less likelihood of a vapor cloud explosion, and even if they do occur, the property values at those facilities tend to be much lower than, say, somewhere like a refinery where there's a high concentration of values. And if we look at some of the more recent losses, so in sort of 2018 and 2019, you might be familiar with some of these. So just to highlight a few of the more highly cited ones. So there's the PES refinery explosion in Philadelphia, which happened in October 2019. That had a recorded loss value of about $750 million. The incident was caused due to the failure of a thinned elbow and an alkylation unit. It should be noted that this site changed ownership around a dozen times over the years before the loss, and this can be seen as a red flag because each transition can introduce the potential for personnel, information records, and systems of work disruption. And this links in with asset age. So it tends to be that older sites will generally have more differing owners than younger sites. There was also the Husky refinery explosion in 2018, and also in the US in Wisconsin. It's believed that the root cause of this was an FCCU spent catalyst side valve, which was intended to be provided with erosion protection suitable for the design life at the design conditions. But this valve had actually eroded and was unable to maintain the catalyst level required to prevent air from mixing with hydrocarbons during transient operations, and the recorded loss was $650 million. So what was the largest loss in this period, in those 2 years? It actually happens to be a petrochemical plant in Jiangsu in China in March 2019, where a major fire and explosion occurred. But there's relatively limited information on the exact causes of this particular event. And from our perspective within insurance and I guess sort of industry in general, the information available on these losses often depends on where they happen. So, for example, in the US, the CSB, Chemical Safety Board, do a great job of investigating and sharing lessons learned, and there's normally lots of really good information that comes from those. However, losses in other parts of the world, there's far less information, and it's not always easy to get concrete information and reliable sources. And if we look at some of the split by sector, so refineries account for 50% of all the new loss additions, petrochemicals and gas processing around 25% each, and there's not been any from terminals and distribution and upstream. Again, so what can we learn in 2018 and 19? So two of the largest losses both happened in the US, the Philadelphia and the Husky, Wisconsin losses I mentioned. And there's been well-publicized regulatory shift over the past 2 years, including the rescinding of most of the chemical disaster rule. So this shift can be construed as potentially representing a lighter regulatory touch from the Environmental Protection Agency, which has removed some of the following safeguards. So, such as the requirement that chemical companies must determine the root cause of spills or explosions, the requirement that an independent third party investigates spills, explosions, and other disasters, training requirements for supervisors of plant operations, the requirement for the plant owner or operators to keep safety information up to date, and the requirement that plant owners release chemical hazard information to the public upon request. As you sort of mentioned, the largest new refinery loss occurred at Philadelphia and was triggered by a thinned pipe elbow installed almost 50 years earlier. And it was reported that this was found to contain a metallurgy permitted when it was originally installed, but not under recommendations made 20 years later by the American Society for Testing of Materials. So, similar losses could occur in future if aging assets are not supported by evolving engineering standards enforced by adequate regulation. And this is sometimes, a key area of process safety management is, have standards changed? Have things moved on? Is there new knowledge and technology that maybe means that what was acceptable 50 years ago is not acceptable now, or is not acceptable 20 years ago? And if we look at, what could potentially be causing these, so at the end of 2017 and into 2018, US refinery utilization stood at its highest level since 2005. And this high utilization continued over the past 2 years and potentially could contribute to the number of high recent losses. Downstream margins are usually positively affected by drops in oil price, and this can result in refineries being pushed to operate at greater capacities, and that can then potentially lead to process safety being impacted and increased events. You've also got the potential impact going forward of COVID-19. So while this might, and the global pandemic, so while this might reduce utilization, it could also lead to cost reduction exercises, reductions in maintenance and inspection and asset integrity spends, which sometimes when we look back at data can cause sort of lagging process safety and loss incidents. So some of the data that Marsh collects relates to looking at engineering standards. So Marsh has a risk ranking system that we use to rank clients, sites in areas of installed hardware, management systems used. So, for example, systems of work, permit to work, management of change, emergency response. This has sort of over 400 features that we rank within various topics and categories. And when we look at the refining engineering standards, we see there's been a bit of a deterioration in risk quality between 2008 and 2019, and you can see that represented by the dots. So the green for 2008, 2011, and then the yellow dot 2012 to 15, and then 16 to 2019 in the blue dot. And basically, in essence, external standards represent, we would deem a minimum expectation, and the highest scoring sites that we see demonstrate commitment rather than just a compliance. And they will develop and apply their own standards. What we've also seen is that both gas processing plants and terminals and distribution sites, the risk ranking data that we have shows that there's potentially seen a deterioration across all areas, so hardware management systems and emergency response over the past 12 years as well. So I'll move now on to talking about whether we're seeing any history repeating itself. So, in the past 2 years, we've had has contributed more incidents to the top 20 largest losses than any other 2-year window for 30 years. So it's not since 1988, 89, when there was 6 of the largest losses, has there been such a large concentration. So you can see back in 88, 89, you had Piper Alpha, Pasadena, Gulf of Mexico, the Campos Basin, Nevada, Louisiana, a large number of large value losses. And then in the last 2 years, we've also had a few of those, as large number of losses as well. Jiangsu in China, the 2 refinery losses I mentioned, and Limba in Cameroon as well. So you can see there is a certain amount of, is there potentially history repeating itself? And if we go on to having a look at what are some of the contributing causes and escalating factors. So we'll look at both time periods. We'll start here with the period 1988 to 89. So, for Piper Alpha, there was, many failings, and there was the Lord Cullen report that made a number of recommendations that drove a lot of process safety improvements back in the late 80s and 90s. So some of the failures were work permitting, management of change, especially with the change of design of the platform, shift handover, and also emergency response planning and fire protection as well. We also see for the Louisiana refinery that corrosion was one of the key causes of the loss. You see there's a lot of similar contributing causes and escalating factors. So, systems of work regularly come up, and there's also escalating factors regarding, the emergency response. So we generally see, good systems of work will hopefully prevent a loss of containment event, and then good emergency response and emergency control will hopefully then prevent the escalation of any loss of containment event, or if it does then start to result in a fire or explosion, it helps to reduce the amount of damage caused. And if we then add into this list some of the more recent events, again, we can see that around 3 out of the 4, of these root causes or contributing causes and escalating factors have been observed in the past. Again, we're looking at systems of work, inspection, emergency response planning, and fire protection. So it definitely feels that we're seeing the same sort of contributing causes now as we did back in the late 80s, when we had a large number of loss events then as well. And one of the sort of quotes, so some people may be aware of a man called Trevor Kletz. He was quite a famous author on chemical engineering safety. And he's been quoted saying, "You don't have new accidents, you just have old accidents happening to new people." So how do we prevent history repeating itself? This is it's a continuous process. We need to continue to educate ourselves to focus on process safety and risk management, and to learn from these lessons across all levels of our organization, from top management all the way down to frontline site personnel, and the culture of that and process safety culture is very important, that it's across the whole organization and it's not just in pockets. And I'm sure Lee will talk a little bit on that later on as well, when he talks about the Energy Institute Process Safety Management Framework. If we look at some of the barriers to learning from losses, so one of them, distance. So regulation often follows a major incident, and it's often enforced locally rather than globally, which is can be understandable. It's quite hard to enforce regulation globally, and consequently, this only affects local awareness. And sometimes, in areas where there's maybe not a lot of regulation, and where they haven't necessarily had a lot of loss events, then they won't be learning from this, and they won't be learning from other past loss events. And at the same time, parties can be affected by closeness bias as well. So people will feel unconsciously less affected by events a long way away. Next one is culture. So this can prevent lessons learned from being implemented effectively. So there can be a fear of litigation or blame that prevents open reporting and incidents within organizations. And there can be difficulty challenging upwards in certain cultures and businesses, and that can prevent improvements being implemented. Tunnel vision. So some companies don't realize the wider relevance of lessons. You can have siloed thinking, can cause companies to imagine that an incident happening in a different type of facility from their own does not provide applicable learnings, but that's not always the case, and it's always good to try and learn from others, even if you maybe don't think that it's strictly relevant. And the final one, time. Short corporate memory. So, lessons are learned. You can rely on experience of individuals within an organization passing the knowledge on, but those individuals will inevitably leave or retire. And it's that sometimes a sort of lack of corporate memory and of recording key learnings in procedures and standards and processes that means that can be lost. And that's also a sort of key part of process safety management as well. So given the last 30 years that have elapsed between the two worst periods in terms of the 20 largest losses, then we see that time is a particularly significant factor. And I've got another quote from Trevor Kletz. So organizations do not learn from the past. Individuals learn, but they leave the organization taking their knowledge with them, which is why it's always key to record this and embed it into processes, procedures, and standards within organizations. So what are some of the effects of time, apart from looking older? Loss of experienced people, loss of corporate memory, as I mentioned. Safeguards are put in place following large losses, and sometimes they're eroded over time, or people think they start to become not relevant anymore, and they may be retraced back to existing behaviors. A lack of understanding of how risk can change with the age of a plant, so including creeping or subtle change that's not recognized, and that's the importance of management of change processes and HAZOP revalidation every 5 years as well. Inherited problems if the site changed ownership, as we mentioned before, that can cause disruption and complacency. So something I often hear, has worked fine for 20 years, we've never had a loss in the last 30 years. It can be challenging to maintain focus in the workforce over several decades, but often these loss events are maybe only a 1 in 1,000 years or 1 in a 10,000 year frequency event, as per studies. So, just having a narrow view of, it's been fine for 20 years is not the right way to think about it. And if we look at some of this chart, so this chart shows property damage loss data, and it comes from the Liberty Specialty Market Oil and Gas Loss Database. So Liberty are a large insurer, and they insure a large number of energy facilities as well. And so this discusses the correlation of plant age versus loss frequency and magnitude. So you've got the number of losses on the right-hand side and the ground up property damage loss value on the left-hand side, and then you've got the contribution of the losses from whether it's operations related, maintenance, inspection, fire safety, or design and construction. So initially when plants are sort of less than 10 years old, you have a lot of losses caused by operations related failures, and this is due to, as plant operations experience develops, then the number of losses reduces, and then you will have age taking its toll as facilities get older than 30 years old, and you see a steep rise in loss frequency and magnitude. So if you, for example, for plants that are less than 10 years old, generally a major contributing factor is operated related failures, so such as non-compliance of systems of work, such as permit to work systems. Again, and then if you look between plants aged between 10 to 30 years old, you have a much lower number of losses, and then it increases again when they're over 30 years old, and you're getting a lot more related to maintenance, inspection, particularly mechanical integrity due to the age of the facility. And what we sometimes call this is a sort of a bathtub curve. Another data set, similarly, but this is now done by region. So you can see North America's in the light blue, Middle East and North Africa in yellow, Europe in grey, and Asia Pacific in dark blue. So you can see both North America and Europe, so a sort of a bathtub curve, but it's sort of less, it's not really seen this in the same way with MENA and Asia, potentially because the Middle East and Asia these regions are younger and there's less older facilities, and so they haven't yet reached as much of this bathtub curve. There's not as many of the facilities and data points where they start having those aging issues. And sort of finish off on the 100 largest losses about, does age really matter? Well, this is a nice quote from Ian Robb, who's the global head of risk engineering at Liberty Specialty Markets. So in order to prevent losses involving aging plant and equipment, increasing implementation of an effective mechanical integrity program is vital, and ensuring best practice metallurgy to current industry standards, inspection programs designed by qualified inspectors and corrosion engineers, along with accredited qualifications to those conducting inspections, are all essential requirements. And this is showing the sort of a focus on mechanical integrity inspection, because there's been a large number of failures in this area that have led to significant numbers of losses. And any good process safety management framework should have mechanical integrity should form a key part of that. And I regularly recommend to clients the Energy Institute's process safety management framework, because it's a great resource, including on areas such as mechanical integrity. So just to show the Marsh 100 largest losses publication is readily available. There's a link here where you can go and download it. You can also type it into Google. So if you type 26th edition Marsh JLT 100 losses into Google, you should be able to find it there as well. I might ask and see whether we'll be able to distribute it to the attendees potentially. But please feel free to go and download it and have a look through. It's a very valuable document. It's good for learning lessons from as well, and there's a number of good insights from different people within the energy industry, not just within insurance. To finish off my segment, I'm going to just present a few slides on ammonium nitrate explosions insights. So as many of you may be aware, on the 4th of August 2020, there was a large explosion occurred in the port of Beirut, Lebanon, killing approximately 200 people, and around 2,750 tons of ammonium nitrate exploded. And it was estimated that this was the equivalent to around 500 to just over 1,000 tons of TNT. So this was done by Sheffield University Blast and Impact Engineering Research Group. And I know various organizations have tried to calculated the TNT equivalent, but that's one of them. And this gives you an idea that the explosion was roughly a 20th the size of the Hiroshima bomb, and released 1 gigawatt hour of energy in a few milliseconds. And you can see from the picture there the extent of the damage caused. I'm sure a lot of you saw it on the news as well. And it's believed to be that some of the root causes were the failures relating to the appropriate storage of ammonium nitrate, which can be highly oxidizing and explosive in the wrong conditions when it's stored inappropriately. And sort of following on from the trend of, is history repeating itself? Well, unfortunately, it seems that this is a bit of the case with ammonium nitrate storage. So these are some of the incidents in history of relating to ammonium nitrate over the last 100 years, and you can see there's a large numbers all over the world. Some of them featuring in the top 10 largest losses. So the event in Toulouse in France was very significant, and that features in the top 10. And so it seems that history does repeat itself somewhat. The Institute of Chemical Engineers also recently reviewed 25 ammonium nitrate incidents, and 2 main concerns were highlighted. So Poor safety management systems around storage and handling of ammonium nitrate was the first one. And the second one was the challenges of safe storage and handling of ammonium nitrate, particularly in the training of operatives and responders and their awareness of hazards. So there's a stark difference between hazard classification as supplied and the hazard potential in accident conditions, so the toxic release and explosion. And just to give you some idea of what is sort of ammonium nitrate storage and handling considerations and good practice. So, you want to try and minimize the risk of contamination to exposure, shock, confinement, and heat sources. You want to make sure the storage areas and packing are constructed of non-combustible materials. You want good subdividing of building into storage bays. You want to limit storage height depending whether they're piles or bags or drums, and segregating and distancing between packs, piles and stacks, ensuring there's good ventilation and monitoring of temperatures. Storage buildings being equipped with smoke and heat detection, also trying to protect the ammonium nitrate from absorbing moisture, either through waterproof packaging and sheeting or air conditioning, sealing electrical fittings to prevent ingress of ammonium nitrate dust that then might lead to explosions, preventing or prohibiting smoking in storage areas, and reviewing separation distances to critical infrastructure, residential buildings, commercial buildings within the vicinity of the storage location. There's also considerations for whether you should use fixed fire water deluge systems. So if you're storing over 2,500 tons of ammonium nitrate, then you should consider fixed water deluge systems, and there are standards such as NFPA 13 and NFPA 230 that can give guidance on that as well. Also should consider clear guidance and controls when fuel-powered vehicles such as forklift trucks are in use in the storage areas. And there's a number of publications that can provide more detailed guidance on good practice for storing and handling. So Marsh JLT Specialty produced an ammonium nitrate storage insight. There's NFPA 400 hazardous materials code that has details on ammonium nitrate storage. And then there's also the HSE INDG 230, which is their guidance on storing and handling of ammonium nitrate. So that's my segment finished. I just wanted to say thank you very much for listening, and I hope you found it useful. I'm now going to pass over to Lee for the process safety management framework discussion, and then we will have questions at the end.
Thank you. Thank you very much, Alex. So for the concluding 5 to 10 minutes of this presentation, I would like to present on the EI process safety management framework. We've all just listened to Alex expertly guiding us through the devastating consequences of getting process safety wrong, and I'd like to offer a way for how we can avoid getting process safety less wrong, and even perhaps how we can get process safety more right. And this is by way of the EI high-level process safety management framework, which was published in 2010. So it's 10 years old and is widely referenced and in common use across the energy sector. This slide illustrates the structure of the framework. And as you can see at the high end, we have 4 focus areas, as we describe them, of process safety leadership, risk identification and assessment, risk management, and review and improvement. The 4 focus areas then range across 20 elements, which are key aspects of an operation that need to be managed suitably in order to assure the integrity of the operation. To help to do this, each element contains several expectations which describe what success looks like in terms of what should be achieved to assure the integrity of the operation. And then finally, we have the guidance. Each of the elements have guidance documents which describe how to implement each of the elements. And for the framework itself, which contains details on the focus areas, elements and expectations, these are all freely available to download from the Energy Institute publishing website. As far as the guidance documents are concerned, these are available from the website, from the publishing website, and they're free of charge to all technical partners of the EI technical program. On the latter point, the EI is working with an external organization in developing an online software application which shows a dashboard of indicators based on those described in the guidance documents. And if anybody requires any further information or details on this, please get in touch through Trevor and the Middle East branch. Next slide, please. So having described the structure in the previous slide, this is an illustration of how the 4 focus areas and 20 elements combine and work together. And it's rather a sort of a Battenberg cake slice view. The framework takes as its foundation the first focus area of process safety leadership, and that comprises 5 elements which, taken together as a whole, enable the right conditions and environment for doing process safety in the right way throughout a high hazards business. The second focus area of risk identification and assessment, that comprises 2 elements, including hazard identification and risk assessment. A particular critical stage, because if a hazard is missed, then inevitably it will not be managed. The third focus area, risk management, contains 11 elements, and it is deficiencies in several of these elements which led directly to many of the accidents described by Alex in his presentation, such as management of change, emergency preparedness, inspection and maintenance, and work control. Finally, we have the 4th focus area of review and improvement, which again, as Alex highlighted, we have seen flaws as history is seen to repeat itself, and there's a loss of corporate memory. Next slide. This slide offers another perspective on the framework. This is a barrier model illustration, which shows each of the elements of the framework as layers of protection. In reality, each of the layers will be in a state of degradation. But if the holes in the barriers are allowed to grow unchecked, then they're more likely to line up and result in a major incident. To make this scenario less likely, high hazards organizations need to regularly challenge themselves with the following 4 questions. Do we understand what can go wrong? Do we know what arrangements we have to prevent this happening? Do we know that we are doing what is required by our arrangements? And finally, are we confident that our arrangements will work when required? That concludes my very short introduction to the framework. But what I'd like to add as a postscript is that the framework itself is under revision and is to be published in Q1 of next year. I can say at the moment that there are only minor revisions to its core content. So there's still 4 focus areas, 20 elements with their expectations. But inside that document, there's a greater explanation of how to sell the framework into an organization. And there's also additional guidance on how to implement the framework. Next slide. So that concludes my introduction to the process safety management framework, and I think I'd like to pass back maybe to the moderator, Trevor, for a Q&A.
Okay, thank you, Lee. Trust you can hear me. Got it?
Yeah.
Great. Okay. We have a few questions, and I have a couple of my own because this is a very interesting topic. One of the first questions that came in it may have actually been answered through the presentation, because it came in after about 15 to 20 minutes in. This came from Idris Salim, and he's saying, what are the principal root causes of the 100 largest losses? I mean, is there a serious single or 2 or 3 factors that always seem to occur?
Yeah, I mean, from having a look at some of the contributing causes from 1988, 89, and 2018 and 19, it's often systems of work, a particular inspection management or mechanical integrity management, and emergency response preparedness. Those are the sort of key ones, and they tend to occur regularly throughout industry. Where maybe there's some differences, there have been some large losses in upstream industry relating to vessel collisions. So there was such as Mumbai High, where in bad weather a vessel lost control and collided with one of the gas risers on the outside of the platform, which then caused a release and a fire and an explosion. And there was also the Ecofis incident, where again a vessel lost control and collided with a platform, causing a significant amount of damage. But I would say in general, there's a lot of the root causes come from systems of work, so particularly permit to work, management of change, management of maintenance and inspection and mechanical integrity. And then in trying to sort of reduce the severity is the emergency response planning. So there's a number of incidents where they probably could have been, the severity of them could have been significantly reduced by better emergency response planning.
Okay, taking all of that in, another question is, do you see specific regional differences? I mean, between, say, the US or Europe or places like in Africa, or desert conditions such as we have here, or tropical conditions like they have in Southeast Asia?
I've not seen any data that is specific to I guess the climate, although I imagine that could be an influencing factor. I mean, age definitely seems to be one of those factors, as we discussed in the presentation. So, as facilities age, there is, it naturally becomes harder to manage potentially mechanical integrity. There's maybe lines or areas of the facility where you haven't been inspecting, and they will start to come to the end of their life. And sometimes, changes over time. So poor management of change means that, new inspection regimes haven't been included. So age can be a particular factor. And we find as well, in regions where there's less regulation, then maybe some of the management systems aren't as advanced as in, say, Europe or North America, where there's more regulation and requirement for robust management systems. So, for example, like the HSE within the UK, and their ability to shut down facilities if they don't think they're operating safely. Whereas if you go to other parts of the world, they don't have those sort of regulators, so it relies on self-regulation and learning as well.
You mentioning regulations, it was another topic that's come up. Been sort of watching things going on in the US, and it seems very noticeable. The current president, who may not be present for very long, but President Trump seems to have relaxed a lot of regulations across all sorts of frontiers in the oil and gas industry, in climate change, car regulations for emissions, and so on and so forth. Are there any noticeable ones that you've seen that may ultimately affect the safety in process plants and other operations that they have?
Yes, there was, and I sort of briefly touched on it in the presentation as well, that was potentially some of the contributing factors for some of the refinery incidents was, the relaxation of these regulations. They've reduced the requirement for incident investigations, for training, for publishing data externally, for having third parties do the investigations. So in a way, they've sort of gone, I say gone backwards, but they've reduced the amount of regulation. And for experts within process safety, you would generally say that these regulations generally help to reduce events because they help with learning and learning from history and ensuring that good practices are followed going forward.
Interesting. I was just wondering if you have any thoughts and projections of what may happen as a result of the whole coronavirus thing. Obviously, the data is not in, and we're 8 months into it. But can you see potential problems as a result of reduced workforces? And I know examples I've heard of shifts. A number of people on any one given shift are reduced to avoid and to keep social distancing and so on and so forth. You can see the potential of hazard in that. What do you imagine that might happen?
Yeah, so we have tried to look at that from past data. So trending loss data with oil price can be a classic one. Obviously, sometimes that's inverse between upstream and downstream. So as I mentioned, sometimes when you have low oil price, it can help with refinery margins, but obviously reduces revenue for upstream operators and vice versa. And I know, having worked in the upstream industry, that obviously, when prices do reduce, so there is a certain amount of cost reduction exercises, and they always try and maintain it within the framework of a good process safety management system. But does every site and every client do that appropriately? Does sometimes maybe it cut too close to the bone? Potentially, yes. Maybe things get deferred. Certain maintenance and inspection gets pushed out to next year. So it was always hard to tell, to predict the future. But there is potential there, yes, because with capex and opex reductions and potentially changes in manpower, then that always has the potential to add risk and lead to loss events.
Okay, this one I'll address to Lee. As we all at the Energy Institute know, we have this wonderful tool, this app called Toolbox, which is freely available to everyone, whether you're a member of the Energy Institute or not. It can be downloaded onto your cell phone, which has in that app a whole bunch of incidents ranging from large to small, which are real incidents. It's information provided to us by our technical partners freely and openly. And there's a discussion of the incident, a discussion of why it happened, and a discussion of how to prevent it. And that little app may be of significant use to people out on site, because you can get it wherever you are. You don't have to be sitting in your office. Do you think that sort of thing is useful as we go forward, Lee?
Yes, absolutely, Trevor. I think having the ability to connect frontline staff at the sharp end with an authoritative sources of information is an absolute great thing to do. I think the EI has taken a lead on this and sought partnership from several operating companies in making this app freely available to anybody who's actually interested in learning more about some of the consequences of, as I say, getting safety wrong. So yeah, I think it makes it more real, I think, for many people, and the early indications are that the users are finding it extremely useful. Yeah,
I mean, obviously it's not going to replace your process safety management guidelines, the new edition, but that's a guideline. It's a tome. It's not something that everyone's going to have when they're out in the desert or the jungle or following a pipeline or wherever they are. So we've, I can see the usefulness of the app, and I know it's now available in a number of languages. Hopefully soon, maybe they have it in Arabic soon. Well, I'll push for that. But I can only say to everyone listening in today, to have a look on our website, just put in the search for Toolbox, and you can see, and it's just a phone app, download it, and there's lots of incidents in there, which I say are real incidents. And it's not going to replace the guidelines. It's not going to replace the information, things that people like Marsh and Alex have provided as detail, but it's something that's there and can be readily accessed by anyone and everyone, wherever they are. So I hope you all have a look for that. Well, we're almost at the end of our time. It seems to have gone incredibly quickly. We've a couple of minutes left. I'd just like to wrap up by saying thank you very, very much to Alex, who's, as he mentioned at the beginning, is a member of the EI Middle East board, and to Lee, who's obviously slaved very hard over doing the technical stuff on the process management guidelines over the last few years. So thank you very much to both of you. And whilst this event was organised by the Middle East, it's been a global event, and we're so pleased that so many people from all over the world have been able to participate and listen in. There will be a video available, and we'll see, as Alex mentioned, about providing a link to his 100 cases manual. So we thank you all very, very much for joining us. And as I said, this is a prequel to the HSE and Sustainability year-long event, which starts at 8th and 9th of December. Please have a look at that on our website also. And please, it's free. The webinars will all be free. The first two is a panel discussions, one half a day on sustainability and that, and the other day on all HSE and related matters. So, and the whole year there will be events like this, ranging from informative to panel events to probably high-level technical presentations from EI people who are producing these guidelines, such as the PSM. So thank you very much to everyone. We've just hit 4 o'clock, and so we'll close down before the system closes down. Thanks very much, guys, for doing the event. Thanks to everyone, and bye.
Thank you very much. Goodbye.
Thank you.